Look at almost any animal. A dog wags its tail. A cat flicks it. A monkey grips a branch with it 50 feet up. And then there's you. Just a flat stretch of skin at the base of your spine and a small bone called the coccyx that almost nobody thinks about. So what happened to your tail? The answer starts with a mutation so rare and so risky it should never have spread through an entire species. About 25 million years ago, your ancestors were small, furry, and fully tailed, leaping branch to branch through the trees. The tail wasn't decorative. It actively controlled balance and steering, like a rudder. For tens of millions of years before that, every primate on the planet had one. Then, in one small branch of the family tree, something changed for good. Here is the key distinction most people never learn. Monkeys have tails, apes don't. Humans are great apes, alongside chimpanzees, gorillas, orangutans, and bonobos. All tailless, all descended from one common ancestor that, at some point, lost the tail entirely. For over a century, scientists accepted this as fact without understanding the mechanism. They knew the what. They never really knew the how. In 2021, geneticist Bo Sia, recovering from a skateboarding injury, started wondering about his own spine and asked why apes have no tail. His team compared monkey and ape genomes, hunting for one shared genetic change, and found a jumping gene, an ALU element, that had inserted itself into TBXT, the gene controlling tail growth. One mutation in one individual disrupted it completely. Against all the odds, it spread anyway. Zia's team tested the theory by engineering mice with the same disruption. The mice were born without tails, exactly as predicted. But some were also born with spina bifida, a severe defect in spinal cord development. The very mutation that erased the tail also carried a real risk of neurological catastrophe. So how did such a costly mutation survive natural selection at all? One leading idea involves dosage. One mutated copy removes the tail while keeping the defect risk relatively low. Two copies push that risk much higher. The animals carrying just a single copy survived, reproduced, and quietly spread the mutation, while the species absorbed the danger across countless generations of developmental variation. Neural tube defects remain among the most common serious birth defects in humans today, which is part of why folic acid is recommended during pregnancy. That ancient gamble is still written into human biology, whether you know it or not. But why would losing a tail be worth it at all? Apes are built differently than monkeys. Shorter, more vertical spines, broader pelvises, wider rib cages, longer arms relative to their legs. This body plan favors brachiation, swinging beneath branches instead of running across them. A tail that helps balance on top of a branch becomes useless, even dangerous weight, when your whole body hangs from your arms instead. Paleoanthropologist Jeremy De Silva, who studies the evolution of walking at Dartmouth, argues this was part of a larger transition. As African forests thinned, apes spent more time on the ground, and that same broad, flexible pelvis eventually helped some stand upright and walk. Losing the tail was the first step of a full structural reorganization from the hips up. Your coccyx, the small fused bone at the base of your spine, is what remains. In rare cases, infants are still born with a small, soft tail-like growth, usually removed shortly after birth, proof that the genetic instruction isn't gone, just deeply suppressed. And the coccyx isn't useless tissue either. Biologist Nathan Lentz notes that several muscles still anchor there, supporting your pelvic floor. The tail wasn't deleted by evolution. It was quietly repurposed into something else entirely. You carry this history in your bones, your posture, the forward tilt of your pelvis when you stand. Every time you bump your tailbone, you're feeling the echo of a transformation that began in a forest gone 25 million years. One mutation, one jumping gene, landing in exactly the wrong place at exactly the right moment. So when you press a finger to that small, hard bone at your spine's base, you're touching the evidence of the most consequential accident in your family's history.